Right, so let's start off class with organic chemistry part 3. And let me launch let's go to the first slide. You're presented with two options. Choose one option. These are two horrible options, but which option do you think is slightly better to be in? Do you prefer to be the second little pig from the story who's obviously going to get eaten, or I don't know if you want to take your chances, or do you want to be in Snow White's situation? Give it a read, and we're going to vote in a little while. Think on it. Think on it. Right. Results. It seems that the Snow White option won by a small margin with 57%, and the wolf and the pig 43%. All right, so that means everyone who genuinely chose Snow White, 10 points. For those who chose option 1, 0 points. Keep track of your points, okay? Let's go. Right, so while you're all writing that down, there's a few people who came in slightly late. This here is the general formula for today's topic, alkenes. It's CnH2n. It does not have a +2. And to summarize, alkenes, when we're doing it today, there will be a double bond between the C's. Okay, there will be a double bond. And anything with a double bond between the C's, you cannot call it saturated. You have to call it unsaturated. Let's go. Let's move on to the next slide. And let's name some alkenes. So we're using the same table from last week, right? Meth, et, prop, but, and so on. That comes before the name. That relates to the amount of carbons. The first one, right? C, 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 and C. That's 4 carbons. Now, when you're naming alkenes, you not only have to pay attention to the amount of carbons. We know this question, the first question, has 4 carbons. So its name will start with but, B-U-T. Now, I'm going to do the wrong thing first, right? This first one, it's going to be called but, and since it's a alkene, and we know it's an alkene because there's a double bond and only between one pair of C's, right? This is slightly wrong. Whenever you're naming an alkene, you not only put the but and the ene, but you have to tell the examiner where the double bond happens. Now, you have to pretend that you're walking from on both sides of the alkene. Which side will you reach the double bond first? Obviously, if you walk from the right-hand side, you always have to choose the shorter route in order to reach the double bond. Now, if you choose the longer route, like you walk from the left-hand side, if you jump on the first C, you cannot access the double bond. You cannot. If you jump on the second C, you cannot. But by the third C, you have access to the double bond. You come in contact with the double bond. But like I said, that's wrong. In this question, you have to choose the left-hand side. This particular question. When do we reach the double bond? On the first C, because when we jump on this C, the first C makes contact with the double bond. So you have to call it 1-butene, meaning that the double bond touches the first carbon. You have access to the double bond from the first carbon, and that's a shorter route. I know somebody is going to ask, is it still correct if we go to the longer route? No, it's 100% wrong, and that's the purpose of me saying it like this, right? But there are 2 ways to write our answer. Some people will put the 1, a dash, and then the name of the alkene. But some teachers and some textbooks do it like that. But, they put a dash, 1, and ene. both of these are considered to be correct, right? You can put anyone in my class, but when you go to school, ask your teacher which one do they prefer. You know, some teachers have a preference, right? And most teachers are not going to dig a fuss about which one you do, right? Right. Now, that's the name of the first one. Also, if you leave out the one, right? Like let me say you leave out the one and you just put butene. If you leave out the one, then it is automatically assumed that the double bond occurs on the first. In other words, when you leave out a number, you assume that the first, it is one, right? But in this class, I don't want you to leave it out. I want you to put in the one if it is one. Can you all name the second one for me? You choose any format, whether you want to put the number first or you want to put the number in between. I'm going to leave it up to you guys. Choose one. What's the name of the second alkene? Send it on the chat, right? Right. So remember, look at the double bond. The double bond comes off the first carbon. And this one is the same thing as the last one. If we walk from the right-hand side, you see it connected to the first carbon. So his name, and it have how much? 1, 2, 3, 4, 5. So it's 1 pentene or pent, that's not what? Pent 1 E. And well, from watching the answers, I think well, everyone had it correct, which is good news. All right. All right. So let's move on, right? Sorry. Right. This one, oh, by the way, I want to point out something, right? This one, it doesn't have much here. I'll work out this one. But you notice this one looks a little bit different. I mean, not only the double bond. You all notice like most carbons, like if I choose this carbon here, it has how much? It has 4 bonds coming out of it. 1, 2, 3, 4, right? And this one here, you notice this carbon, it still has 4 bonds coming out of it. It has 1, 2, 3, 4. What some people might do by mistake, you have to be real careful when you're drawing an alkene. You have to make sure that to a carbon, you have 4 bonds coming out of it. You cannot have more than 4 bonds. In fact, you must have exactly 4 bonds. So I just want to show you a common mistake made. So what I'm going to do, you see the beginning here, it have 1H and 2H. You see how this one on this end has how much carbons? 1, 2, 3, right? It has 3 hydrogens connected to it. Some people might make the same mistake on this side. So let me show you the mistake. I'm going to erase this hydrogen here and this hydrogen here. And if we do that, some people might do it like this. They'll put a hydrogen here, a hydrogen here, and a hydrogen here. Because they're seeing 3 hydrogens on this end. So you look for symmetry. You put 3 hydrogens on this end, and they think they have it correct. But that's going to be wrong. Let me show you why. Look at how much bonds are touching this C now. 1, 2, 3, and you have 2 here. That's 5. This is wrong, right? So whenever you have a double bond involved, expect less hydrogens at a certain point, right? And make sure and do your count up. Make sure you check each carbon and ensure, hey, it only have what? 4 bonds touching each carbon. It takes a little bit of practice, right? So the correct way of doing this is to only put 2 hydrogens. And no, the 2 hydrogens don't have to be slanted. You could have put the 2 hydrogens straight if you want, like straight up like this. right? But, you know, most teachers are going to put it slanted. It looks cooler. That's the only reason for it. It looks cooler, right? And the name of this particular alkene, and I know it's an alkene, has how much carbons? 1, 2, 3, 4, 5, 6. And this time, to reach the double bond, we walk from the left-hand side. And we're able to make contact with the double bond, right? We're able to make make contact with the double bond with the first carbon again. So his name is 1-hexene or hex 1-ene. Okay? Oh, that's all. 1, 2, 3, 4, 5, 6. Everybody with me so far? Easy stuff, right? Now, don't worry, I'm going to be talking about that double bond and making sure that you have 4 bonds touching each carbon all the time. Also, I want everyone to do a check. Does this formula hold true for this? In other words, I'm asking, does this formula work for this alkene? Let me know. Do a check and tell me if that formula actually works. Does it actually work for hexene? Let me know on the Remember, the formula for an alkene is different. It's CnH2n. There is no +2 like last week for alkenes. How much carbons does it have? 1, 2, 3, 4, 5, 6. So we're going to pretend the letter N is 6. To calculate the amount of hydrogens, it's 2 multiplied by N. We're pretending N is 6. So 2 by 6 is 12. So that means for this alkene, if I have 6 carbons, then I should have 12 hydrogens. Is that true? Do I have 12 hydrogens? Let me do a little count up now. Right? Let's do a little count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The formula is true. And all alkenes will obey that formula. Just like how for alkenes, that had a formula, and all alkenes obeyed that formula. The same thing for alkenes. Let's do something a little bit harder now, right? Let's go. Name this one. Name this alkene. I just want to point out something. Any carbon that we choose here has 4 bonds, and I can prove it. If we choose this carbon, it has 1, 2, 3, 4. Even if I choose the other carbon next to it, this one, it has 1, 2, 3, 4 touching it. Any carbon you choose there will have 4 bonds touching it, right? And we know it's an alkene because we see a double bond between one pair of C's. Good luck. Name it for me. And, you know, this one has a slight trick in it. Real slight. Not even a big trick. Now, its name, it has 6 carbons. Let's do a check to make sure. 1, 2, 3, 4, 5, and 6. So we know it's hexene. It is just a matter of what number to put. Now, this one here, if you walk from the left-hand side, 1, 2, 3, you're able to access or make contact with the double bond by the 3rd carbon. But let's test the other side. You start walking from the right-hand side. You jump on the 1st carbon, jump on the 2nd carbon. Hey, we jump on the 3rd carbon, and we're able to make contact with the double bond. This one is symmetrical. It doesn't matter which side we walk from. In either case, we get 3. So the answer is 3-hexene or hex 3-ene. All right? So some people had 2-hexene. I think it just count wrong, right? Right? So make sure you see your mistake. And of course, you know, make a mental note of it. All right. For those who got it wrong, just let me know if you finally understand it now, right? There's nothing wrong with getting it wrong. You all know me by now, right? Just try your best. All right, let's go. All right, I think y'all deserve a small break there. All right, so we're gonna have another vote just to take the stress off, right? Who do you think is cooler? Superman or Batman? This should be a close call, right? So have a good look, think it through, think through everything you know about Superman, and think through everything you know about Batman. Let's see. Let's launch the polls. Superman is 1, Batman is choice 2. All right. Let's vote. And Batman won. I'm a big fan of Batman. Boo for Superman. Boo. All right. So all Batman supporters, 10 points. All Superman supporters, 0 points. All right. So keep track of your points. Keep track of your points. Batman, 10 points. Superman, 0 points. And you have to be honest, obviously. Right? Let's go. So now we know a little bit about alkenes. Let's talk about their reactions. All right. Um, I want you all to do me a favor on scrap paper only, just so we can keep track of it, right? So you're gonna have to keep referencing it back. When it comes to alkenes, there are 2 major categories you have to remember. If you look back at your notes from the first or second week, I gave you a list of reactions. It was last week, actually. A list of reactions for alkenes. That was to show you how alkenes behave. Well, alkenes, obviously for the syllabus, behaves in a certain way when you mix it with other chemicals. Right? So just do me a favor, just write this alone. Nothing else on a blank sheet of paper or on a scrap piece of paper. That's all I'm asking. Let me know when you're finished writing it out. All right. So just like alkenes, if you look back in your notes from last week, alkenes burn in air, or well, it's the oxygen in the air that it burns with, right? So both alkenes and alkanes, you can create a flame with them, right? You could set it on fire. It's flammable, okay? Now, however, how they burn is different. If you compare, like if I get an alkene and an alkene, and I set both of them on fire, they will catch fire, but the alkene flame will look different from an alkene flame. In other words, an alkene fire will look different from an alkene fire, and you can spot it a mile away. Alkenes burn with a yellow flame. Look at it, and I have a little picture here, and you just get smoke from it. It's not clean, it's a dirty flame. Turn back in your notes and on the chat, I just want you to describe how an alkene flame looks. If you can just get it back from your notes. Do alkenes burn with a yellow and dirty flame? Or is it different? And of course, I did say it's different, but I want to know how different. How is it different? This is me giving you an excuse to go back in your notes and look for the answers to familiarize yourself. I'm making you revise and smart here. But send the answer on the chat to repeat the question. How is an alkene flame fire different from an alkene fire? Remember, an alkene is blue, not yellow, and it's clean, meaning that there's no smoke particles, no black particles coming out of the flame. All right? Right. And of course, you have to memorize, unfortunately, you have to memorize this here for the examiner. This is an example. Now, there are so many different types of alkenes. It have what? Methene, sorry, no, not methene. It have ethene, pentene, hexene, heptene, octene. It has so much, right? Now, you could burn all of them, but you need to memorize the reaction of one of them, at least for the examiner, by heart, right? So here we have an alkene, and I'm going to ask you to prove it just now, right? To ask you what kind of alkene is this, and if it's actually an alkene. When you take the alkene and you mix it with oxygen in the atmosphere and you set it on fire, remember, you can't really have, well, when you're trying to burn a flammable substance, whether it's diesel or gas, you need oxygen, right? You cannot burn oxygen you cannot burn something without oxygen. So when you mix this alkene with oxygen and you set it on fire, you get three things: carbon dioxide. Well, this is steam because it's H2OG. I explained that the G is gas. So this is a gas form of water. So that's steam. And this symbol means heat. You get plenty heat from it, right? Triangle H, negative. Okay, that means it produces heat. My question to you is, right? What's the name of this alkene? And is it an alkene? Am I trying to fool you? Let's answer those two questions. Is C2H4, is that an alkene? And if it is, what is its name? What's the name of that alkene? I'll give you a minute to think it through. Send an answer on the chat. This came up. Remember, an alkene follows the general formula CnH2n. There's no +2. That means if I have two carbons, I'm pretending N is 2, right? Look at that. That means I have to pretend the N is 2 here. 2 by 2 is 4. Yes. So for it to be an alkene, if the amount of carbons is 2, we're supposed to have 4 hydrogen. And we have that here. So C2H4 obeys the formula for an alkene. So yes, thumbs up. It's an alkene. What's the name of the alkene? Right? Now, the name of this alkene, it has 2 carbons, right? So he will be what? F-ene, right? Remember, if you only have 2 carbons, right? The only way it could be rearranged is like this, right? So this one is symmetrical, right? Because to access the double bond, it doesn't matter if you walk from the left-hand side or right-hand side. Both of them will touch the first carbon from the direction that you're walking. So if I just call it ethene, the 1 is understood. So if you want to be real specific, 1 ethene or F1ene. All right, any one is correct. Even if you put ethene alone, any sane examiner is going to give you it correct, right? You're going to get it correct. Right. So I have another question, right? I'm going to put the name of an alkene on the screen. Methene. Tell me what's wrong with me writing the word methene. Ethene is when it has 2 carbons, right? Meth is when it has 1 carbon. So what is wrong? And the answer is not me putting 1 methene or meth1ene, right? It have nothing to do with that. Why am I not allowed to write the word methane in chemistry? Give me a reason. Why am I not allowed to write the word methane? Methane means an alkene with 1 carbon. But something's wrong with that name, and you're not allowed to write it. What's the reason of this? Remember what one of the key features of an alkene is that you must have a double bond in between two C's, right? You must have a double bond in between two C's. Methene means it have one C. So there is no other C to have a double bond in between. In other words, methane doesn't exist. I mean, methane can exist because methane, which is an alkane, doesn't require double bonds, right? But methane it does not exist. All right, so I hope that that clears up that mystery. And I'm sure when your teacher teaching it in school, he gonna drop that riddle on you. Why? What is wrong with methane? Why can't we say it or write it? And now you know the answer, right? It doesn't exist. Right. Let's move on. Right. Now, so we're done with this one. Now, alkenes undergo something called addition reactions. Do me a favor, right? And we're doing it on scrap paper. I want you to take down everything on the screen and leave a space here for the answer. Just leave a space there for the answer. But I want you to physically write this so it's etched into your memory. Now, I have a slide mistake. Anybody see the mistake? It's alkenes. I put oh god. I do this probably for every slide. I put alkenes. It's supposed to be alkenes here. I don't know if anybody spotted that mistake. Right. Sorry about that. Right. I think I have this mistake on every slide for the next 2 or 3 slides. Okay. Great. So alkenes undergo something called addition reactions. Now, it's different from alkenes. Last week, I showed you alkenes underwent something called substitution reactions. Substitution and addition are different. Substitution means one, like in football, one person comes in and one person leaves. It happens one at a time, right? Two people cannot go on the field at the same time, like as that. Substitution means somebody comes in and somebody leaves. An addition reaction is different. People come on the field, but nobody leaves. That's a key difference. Addition means, like if it's football, and you add 2 players on the field. You didn't substitute her. That means 2 players just run on the field. And one team has 2 extra players than the other team, 2 more than the other team. So how do addition reactions look? Here we have an alkene, and this is ethene. More specifically, 1-ethene or F1-ene. Call it any one you wish, or if you just want to call it ethene. Anyone is fine with me. Let's say we take ethene and we mix it with a chemical, and the chemical has 2 parts. I'll just give you an example. Like AB could be sodium chloride, where the first part is sodium and the next one is chloride. Or it could be what? Cl2. Remember, chlorine is diatomic. When you have chlorine by itself, it exists in a pair. So the first one is chlorine and the next one is chlorine. A represents the first chlorine atom. B represents the next chlorine atom, Cl2. The point is, we're adding 2 things to the alkene. What the alkene will do, it will say, hey, we don't do substitution reactions. We do addition reactions. It will say, hey, A and B, you all want somewhere to live? Come by me and live. It will invite them into its house, and everybody gets a space in its house, and nobody gets kicked out of the house. So look at what's going to happen. It's going to tell the C's are like the boss of the house. It's going to tell the H's, make space for A and B. They need a space to live. So the H's are going to straighten out themselves, right? Look what's going to happen, right? One key thing that's going to happen, you notice it have a double bond here. In the diagram, the double bond disappears. So the double bond between the C's change to a single bond. That's the first thing. And then the H's will begin to straighten out themselves to make space. They can straighten them out anyhow, right? I just straightening it out like this, right? So you notice it have 4 H's here. It have 4 H's, and the double bond disappears. And then, since one of the double bond disappears, just imagine it like this, right? This double bond that disappears, it breaks itself into half. One half here and one half here. And then the A and the B gets a space to live. That is an addition reaction. A and B were added into the structure. There's no substitution happened there. Guys, addition. Everybody gets a space to live in the house. Everybody with me so far? And just remember, there will be no more double bond, right? Imagine that the double bond that got removed, that it break itself in half, so A and B could get a space. Okay? That is an addition reaction. Everyone draw this for me and take down this note here on scrap paper. Right? And by the way, it doesn't matter if the A and B are underneath or if they're on top, or the A is to the left and the A is to the right, right? They just get incorporated into the structure, right? Most teachers draw them underneath. Doesn't really matter. Give you a minute to take down. All right, let's get ready to go. You're gonna see now this is a general type of reaction. Now I use A and B. Obviously, when I do some more examples, I'll put real things there to represent in place, sorry, of A and B. Like how I use the example of chlorine, right? Sorry about it. Right. So what's going to happen over here? Let's say we add hydrogen to an alkene. So once again, we have ethene here. I'm gonna stop putting the one. When the one is understood, and I'm gonna stop putting the one, just to make my life a little bit easier. So here we have ethene, and we decide to add hydrogen to it. Remember, hydrogen is H2, and hydrogen is diatomic. When hydrogen is by himself, he always exists as a pair. So this here is the same thing as H dot H. This come like A and this come like B. What's going to happen here? The ethene is going to say, hey, there are 2 homeless hydrogens here. Let's make space for the 2 hydrogens in our house. So the hydrogens, they straighten out themselves like this, right? And then it tells these 2 hydrogens, come and live with us. And the 2 hydrogens come here. Notice the double bond no longer exists. Anybody could tell me the name of this compound? What's the name of that compound? We started off with ethene, we add hydrogen, and it just so happens alkenes undergo addition reactions. You all realize we got ethene. You all realize that? We started off with ethene, which is an alkene, and then you ended up with ethane, which is an alkene. So this is a simple way of creating an alkene if you only have an alkene. Let's say you have a factory and you need alkenes, but somebody went and buy a whole set of alkenes by mistake. And the company you buy it from say no refunds. What you gonna do? All you need to do is buy some hydrogen and mix it with the alkene, and you will get an alkene. So that's a simple way of creating alkenes from alkenes by a process called hydrogenation. And its name makes perfect sense. Hydrogenation means you're adding what? Hydrogen. You can't ask for a simpler name to represent a process. I want everyone to draw this week. Take it down on scrap paper, write it back, right? If you have different colors, everything I write in pink, you probably write it in red or a different color, right? Right. Now, for this syllabus, right, you will not be meeting alkenes with more than one double bond. Now, that's off the syllabus, right? So all the alkenes that we are doing will only have one pair of double bonds, okay? Right. So that was just called hydrogenation. Like I said, the name makes perfect sense. You're adding hydrogen. There's another type of addition reaction when it comes to alkenes called halogenation. Guess what? Halogenation means you're adding a halogen. It seems like this part of chemistry really easy, right? I usually find things in science, like when they assign a name to something, sometimes just wonder, well, why that person call it that? That doesn't make no sense. This is the one time you cannot complain. Let's take ethene again, right? Now, obviously, this doesn't only work for ethene. It will work for pentene, hexene, octene, right? But we keeping it simple. We're using the simplest type of alkene. Halogenation means you're going to add a halogen. For the CXC syllabus, halogens are in what? Group 7. So it's things like chlorine, fluorine, bromine, and iodine, sorry. Those are the 4 halogens that you're required to learn off by heart for the CXC syllabus. So let me just choose one. Let me choose bromine, Br. All halogens are diatomic. So whenever chlorine, fluorine, bromine, and iodine is by itself, it exists as a pair. So this is really Br dot Br. This come like A and this come like B. Obviously, what's going to happen here? Ethene is going to say, hey, make space for bromine. He needs a place to live. So, oh, let me color code it. Sorry, I like to keep it color coded. The original structure, the double bond disappears. The hydrogens straighten out themselves. And it has 2 spaces below here. And the bromine says, thank you. Now I have a place to live. That's halogenation. And it doesn't matter if I put chlorine, fluorine, or iodine. They would just take the space of the bromine. And once again, the double bond has disappeared. All right? Take down that example on scrap paper. All the examples we're going to do here for the time being, do it on scrap paper. Get accustomed with drawing it, seeing it. So when you finally do back your notes properly, you're going to understand everything. Let's move on. Hydration. What is hydration? Guess what? When you hydrate, that means you're drinking water. So hydrogenation means you're adding hydrogen. Halogenation means you're adding halogens. Hydration, don't mix up hydration with hydrogen. It has slightly less letters. Hydration means you're adding water as steam. In other words, you're adding H2O. Now, here's the thing. If you take ethene once again and you add steam, water, in other words, you're adding H2O. H2O seems like 3 things, 2 H's and an O, right? 2 hydrogens and 1 oxygen. So it doesn't resemble A dot B. However, whenever you're adding water, water actually doesn't break up into 3 parts. It breaks up into 2 parts. Let me write it here. It breaks up into one H and an OH part. This comes like A, and this whole thing comes like B. It's still H2O, 2 H's and 1 oxygen. But whenever you're mixing water with something, water usually breaks itself into H and OH. Water does not break up into H2 and 1 O. One of the H's joins the O here. All right? So be real careful about that. So what happens when you take water and you mix it with ethene? Well, let's see what happens. The H's, says, hey, let's make space. Let's make some space for that guy. So the H's rearrange themselves. This time, I just put it here, right? I'm doing it the same way. And what's going to happen? The H and OH will get a space. An H will go here and an OH will go here, right? Now, I'm just letting you know, most of the times, and there's a pretty good reason for it, right? But I'm not going to get into the reason. You see, when OH gets pulled into the structure or added to the structure, because it's a type of addition reaction, for some reason, which I'm not going to get into right now, they like to put the OH over here. In other words, they would put one of the H's down here, and they would put the OH over here. Now, don't get me wrong, whether you put the OH here or down here, it's still 100% correct, still 100. But you're going to realize most textbooks and your teacher, whenever an OH is involved, they like to put it on this end. And like I said, there's a very good reason for it, right? Right. But here's the thing. To mix water with ethene, you can't just put it in a test tube and swirl it around. They won't mix. They only mix under certain conditions, and you have to memorize it for the examiner. The examiner could say, hey, complete the drawing, and you could complete it. And then they will ask you, what conditions does steam, but remember, this is steam, I had to put G here because it's a gas. This only happens when you heat the mixture up to 300 degrees Celsius, and you have to add phosphoric acid and the atmospheric pressure. You have to increase the pressure around the experiment to 60 atmospheric pressure, right? That's the only way these two things will mix together, and you get a mark or two for specifying the conditions. Yes, sorry guys, but you have to memorize this by heart, right? 300 degrees Celsius with phosphoric acid in a silica catalyst at 60 atmospheric pressure. That's the only way these two things will mix to give you this. By the way, I don't think you have ever met anything so far in this class that ends with OH. Like you didn't meet anything. Alkenes didn't have an OH. Normal alkenes don't have an OH. Whenever you see something ending with OH, it's actually classified as an alcohol. I know you all know this word, right? Alcohol. But here's the thing. When people hear the word alcohol, they usually think about beers, rum, whiskeys. In other words, the type of alcohol people drink, okay? The truth is, there are many different types of alcohol. Some alcohols can be consumed while others cannot be consumed. It just so happens, right? All alcohols end with the word anol, A-N-O-L. If the alcohol has 2 C's, it's called, but this particular alcohol is called F because it has 2 C's and it ends with anol. It just so happens ethanol is the only type of alcohol that is currently consumed, that's safe enough to consume by humans. There are other different types of alcohols. It have methanol. You all know bay rum? and limacol. How much of you all know that? Like when you have a headache, right? Your parents just pat your head down with either one of the three. Alcohol, there's either pat your head down with Biram, Alcalado, or limacol. And it just make your head feel kind of cool, right? Now, the type of alcohol found in Biram and limacol is methanol, which is not safe to drink. Ethanol is reasonably safe to drink, but methanol, you drink too much of it, you could go blind. You're going to get serious liver damage, right? You'll wake up you go to sleep with your eyesight, and then you'll wake up without your eyesight. You go blind, right? So, and there are other types of alcohol too. If it had 5 carbons, it would be pentanol. If it had 6 carbons, it would have been hexanol. Those things are not consumed by human beings, okay? Ethanol is the only one that's sold legally for consumption. And I know some of you are going to say, you know some people, right, who drink methanol. They would go to the drugstore and they would buy beer rum. They would buy limacol and they would put it to chill in the fridge and drink it, right? That's super dangerous, and people like that usually die very, very quickly or go blind, right? But people still do it because for some reason they're addicted to it. I don't understand it, right? So that I know a few people would ask that question, like how come some people drink beer rum? You're not supposed to be drinking beer rum, okay? Right. Take down everything on the screen here. Let me know when you are finished, and of course, take it down on scrap. All right, think you deserve a small break there. Okay, so there's a little competition here that you have to, somebody is willing to give you $10 billion, but you have to do something. Which one is the better option here? I don't know. Both of these look horrible. Read the options. Which one would you prefer to do for $1 billion? I mean, 10, not one, $10 billion. I don't know. Let's begin. Let's launch the polls. Results here. And the poll, well, it seems that choice 2 is the most popular one. Personally, I don't think you'll realize how dangerous a whole basket of scorpion peppers is. I think that would surely kill you or give you permanent intestinal damage. That would be probably probably die from that. At least number one, in my opinion, you have a chance of living, right? So anyway, the class speaks. So for those who chose the peppers as choice 2, 10 points. We fellow Kangaroonians, 0 points. All right. Keep track of your points. Keep track of your points. Right. Good luck. Now, good luck for the next rounds. All right. Now, here's another thing alkenes can do. You can link them together. Let me say we get one molecule of ethene and another molecule of ethene and another molecule of ethene. Now, they just don't link together. It's under certain conditions. You all know plastics. Everybody knows what a plastic is. That plastic bags, your computer case made of plastic, parts of your clothes, nylon, all those things are made up of plastic. We can't live without plastic. Guess how they make plastic? From alkenes. The same alkenes we're talking about is how you make it. Now, here's the amazing thing. Ethene, alkenes are normally liquids and gases. Ethene or an alkene by itself doesn't even resemble plastic. It's like a gas, so it's a liquid. But when you start to link them together under certain conditions, they begin to form plastic, which has a completely different texture to individual ethene or alkenes. Whenever you link alkenes together, that technique is called polymerization. Poly means many, which means you link many ethenes together. Now, when you're linking them together, you're not linking one or two together. It's like 50 and more, sometimes thousands together. And here's what happens. I don't know if you all notice this diagram here, right? You have ethene here. The ethene has a double bond. When you link them together, the letter N represents how much you're linking together. But it has to be more than 50 to call it a polymer, a type of polymerization. When you link them together, you notice each box here. Notice the ethene starts with 4 H's. When you start to link them together, the double bond disappears and the H's straighten out. And the double bond, the double bond that goes missing, one of the double bond that goes missing, links it to the other ethene molecule. And this goes on and on and on and on. Obviously, I say 50 and more, but I only draw like 4. 1, 2, 3, 4. Obviously, I wasn't going to draw 50 and more. All right? Okay. No, but here's what. You don't have to take this down, right? Because polymerization is the last topic we do in organic chemistry. It's usually the last. And you're going to be discussing the different ways of linking alkenes together. There's not only one way to link them together to get plastics, right? And you'll realize you have different types of plastics out there. And plastic bags just be way weaker than a PVC pipe. And PVC, the same pipes that bring water to your sinks and whatnot. And that much harder. And what about a pool ball, with the game pool, right? A pool ball is made from plastic. Look how hard and heavy that is, right? It's crazy, right? There are many different types of plastics out there. And like I said, the last topic we're going to be doing is how you create all those different types of plastics and the techniques for it, right? So let's move on. Now, how do you know whether something is an alkane or an alkene? Let me say I give you a test tube and it have a liquid in it. So it's a clear liquid. Both alkanes and alkenes, if it's a liquid, both of them are clear, right? Both of them. So how you're going to know if it's an alkane or an alkene? Now, it just so happens there's a test for it. And we're not going to do the whole thing today, right? I just kind of setting you up for it. We're coming down to the end of class. I don't know why this always happens. Coming down to in my slides is just coincidence. The last set of slides is always be the hardest part. And that's when everyone is at their most tired, their brain tired at that point, okay? But I'm going to give you a little introduction. It's 3 things you need to know. How much people in school have been introduced to these 3 substances. Now, these 3 substances are not alkenes or alkenes. These 3 things on the screen are used to test for alkenes or alkenes because both of them look the same to the eye. Bromine vapor, bromine water, and acidified potassium magnate 7. How much people have seen this in school? Right? You mightn't have seen this one, right? The teacher might not have exposed you to bromine vapor, but I want to believe that you all saw bromine water and the purple one here in real life, right? These 3 things can react with alkenes or alkenes, but it is react differently. So if you know what reaction to expect for alkenes or alkenes, you can easily tell the difference. Okay? So let's move on to the next slide, right? All right. You notice these things, let me show you. You notice these things have colors, like bromine vapor is brown, bromine water kind of brownish. and acidified potassium manganate is purple, right? When you mix alkenes or alkenes with these three things, it has the potential to decolorize it. In other words, remove the color from it. So let's look at the table. Alkenes and alkenes. If you have bromine vapor, right, and you mix it with an alkene, remember bromine vapor is brown, right? You all saw the color just now. Bromine vapor is brown. The alkene will decolorize the bromine vapor. In other words, the bromine vapor, which is brown, if you mix it with an alkene, it will turn clear. The bromine vapor will lose its color, but that happens very slowly. It will take many minutes, probably about 5 or 10 minutes, for the bromine vapor to lose its color. However, if you take bromine vapor and add it to an alkene, it will do the same thing. The bromine vapor will become clear. It will lose its color, but it will happen very fast, almost instantly. So that's one way of testing if it's an alkene or alkene. You get some bromine vapor, and if the decolorization, if the bromine vapor loses its color fast, it's an alkene. If it takes its time and loses its color, it's an alkene, right? Of course, this doesn't tell you what kind of alkene or what kind of alkene. It could be pentane, it could be butane, it could be ethene. It just tells you if it's an alkane or an alkene. It doesn't tell you which one of them it is. And if you take, let me say you don't have bromine vapor, which is a little bit dangerous, right? Let's say that you have bromine water instead, which is a little bit more safe to deal with in the lab, which is why I believe most teachers will use this in the lab. They won't really use the bromine vapor, right? If you take an alkane and mix it with bromine water, nothing happens. The bromine water will stay brown. It's like you waste your time, nothing happening. You look like a boops, right? But if you take that same bromine water and you mix it with an alkene, bam, the bromine water becomes clear. It loses its brown color. And acidified potassium manganate, that was the kind of purple thing that you see. If you take that substance and mix it with an alkane, nothing happens. But you take that same potassium manganate solution, that pink solution or purple solution, and you mix it with an alkene, bam, it turns clear. Right? So you have three ways of telling the difference between testing for an alkene or an alkene. And guys, when you're making your notes, please, when you have tables and things to draw, do it real neat now. And it's not good enough just to write the notes back properly in your books. You have to spend some time before class to revise it. So when you come to class next week, I don't have to waste time revising or kind of jogging your memory all the time what happened last week. You have a responsibility to come fully prepared. All right? Let's move on. Let's try one more now before we leave here today. I know it's coming close to the end of class. Which movie franchise is better on the whole? Now, I'm talking about all the episodes, right? Let's see. Which one do you all prefer? Can't remember this one. Guardians of the Galaxy, which I thought was pretty cool. Or do you all prefer the Fast and Furious franchise? I think that has about, I can't remember how much parts that have, probably about 10. But I think Guardians of the Galaxy is 3 or 4 parts, right? Which one did you all enjoy more? Let's launch the polls, right? So let's end this. One has won by a landslide. It doesn't matter if everyone voted. The one that I don't want to win won. All right. Fast and the Furious 1. I have only seen about 2 of all the parts. Sorry, I'm not a fan, but the class has spoken. So Fast and Furious people, 10 points. We Cool Guardians of the Galaxian people, 0 points. All right, add up your points, guys. Let me know how much you got in total before you leave here today. Right, and guys, I just want to point out one thing, right? I know a lot of y'all have been asking about the paid classes in September. Give me till next week now. I'm still doing up the timetable and everything for September. But tell your parents by next week, I will have everything ready. I'll have the flyer ready, the prices, everything, right? I just want to kind of just get the free program out of the way before I, start talking properly about the classes in September. All right? Let's just try to enjoy the free summer program for the time being. All right, let's try to do that. Okay, guys, wait, some people got 40 points. I wonder if they cheated. So, all right. Well, guys, thank you for playing today and thank you for participating in class. And I'm hoping to see everyone here tomorrow for AdMaths, where we're going to continue quadratics. Okay? Take care, guys. Have a good day. I think you have IT later, so please come out for IT class later with my brother, is the other Mr. Sinanan. Right. See you all. Hopefully, I'll see you all in about half an hour to 45 minutes for IT class. Take care, guys. Have a good one. Don't let me hold you back.